Okay, so this is the second part of our 3.5 lesson on completing the square. Before, in the first day, we talked about what number we needed to complete the square, and then how to take that perfect square trinomial that we create and write it in factored form as a square of binomials. So today we're going to use that same method and apply that to turning an equation from standard form into vertex form. So let's take a look at that. So here we have the equation y equals x squared minus 4x plus 10. And so yesterday we talked about how if there's an a value, we have to make sure to remove that a value from a polynomial. So same rule applies here. Anytime your a value is anything other than a positive 1, we're going to go ahead and divide that out. For this specific equation, our a value is 1, so we don't have to worry about that step. Now notice here that our C term, the 10, is not a perfect square. So currently we cannot apply the perfect square trinomial to this polynomial. So what we're going to do is simply focus on the first two terms like we saw yesterday in order to complete the square. So we're going to take those first two terms and we're going to group them together. So we have x squared minus 4x, and we're going to complete the square with just these two terms here. So I'm going to go ahead and rewrite this because in order for us to complete the square, remember we have to add a term to this polynomial. So y equals x squared minus 4x plus some number that we have to figure out. And then this 10 just kind of tags along for now. So recall from the previous lesson that this number here is our 2fg or 2xg. We divide both sides by 2x, and we get g equals negative 2. Now I want you guys to start recognizing that the g value we get that we go ahead and square is always half of our b term. And we're going to start applying that same idea. So if we did half of b, which is negative 4, squared. Half of negative 4 is negative 2, and then negative 2 squared gives us 4. So we're going to start working towards using this to find our g term instead of setting it equal to 2xg every time. So this is now a perfect square trinomial. Now before we move on, I want to go back to solving an equation. Let's just say we had 3x minus 4 equals 7. What would we have to do here to work towards getting x by itself? What would our first step be here? Our first step here is going to be to add 4 to both sides of the equation. So both sides of the equation, we have to add that 4 because we have to make sure that we're keeping our equation balanced. So that same rule applies here. If we're going to add 4 to the right side of this equation in order to complete the square, we still have to add it to the other side of the equation in order to keep that equation balanced. Okay, so always add, when you're completing the square, always add that value to both sides. Now, once we have created this perfect square trinomial by completing the square, we're going to go ahead and now turn that into the square of binomials, just like we saw yesterday. So we're going to take this and rewrite it as x minus 2 squared. Plus 10 stays there, y plus 4 stays here. So we factor the perfect square trinomial and it will always give us the square of binomials. And this is starting to look an awful lot like vertex form, which is our whole goal here. So now, in order for us to have vertex form, we're going to go ahead and get y by itself. We're going to subtract 4 on both sides. And that's going to give us an equation of y equals x minus 2 squared plus 6. And that is how we rewrite in vertex form by completing the square. So let's go ahead and work through another one. Make sure you have really good toolbox items and you're understanding step by step what to do here. So again, first thing, check for A. A is 1. We don't have to worry about that step. So from here, we're going to go ahead and group our first two terms. From there, we need to add a value to both sides in order to complete the square. So we're going to leave blank spaces on both sides. Got a different color. Plus blank in order to complete the square. So to find this value, again, talking about what we looked at on the last slide, we're going to take half of B, which is 12, and square it. Half of 12 is 6, and 6 squared is 36. We add that to the right side. We must also add that to the left side. Now that we've created a perfect square trinomial, we want to go ahead and turn that in to binomial squared. So y plus 36 is equal to, this factors to give us x plus 6 squared minus 7. Our last step is going to be to subtract 36 on both sides, giving us vertex form of y equals x plus 6 squared minus 43. All right, let's just look at a couple more, make sure that you guys fully understand this. Let's look at some with some a values now. So notice here our a value is -1. So the very first thing we want to do is divide that out so that we can complete the square on the right-hand side. Now it's going to look a little bit weird, but just go with it. You'll see it all come together in the end. So we're going to divide everything by a -1. So we're going to just leave this as y divided by -1 because that's going to get undone later. Over here, -x squared divided by -1 is a positive x squared. Positive 6 divided by -1 is -6. -11 divided by -1 is a positive 11. So from here, we can go ahead and group our first two terms together. And we're going to rewrite this as y divided by -1. We're going to leave those spaces to add terms on both sides. So plus a number here and plus that same number here in order to complete the square. So we're going to take half of -6 and square it. That's going to be -3 squared, which gives us a positive 9. That gives us y over -1 plus 9. And now we need to factor this to give us binomial squared. So that's going to be x minus 3 squared plus 11. Last thing is to get y by itself. So we're going to go ahead and subtract 9 on both sides. That's y divided by -1. X minus 3 squared plus 2. And then here we have to undo the division. So we're going to multiply both sides by -1, not -7, -1. Multiply all things by -1. So I said both sides, but we have to make sure we're multiplying it to all terms So these divide out, leaving us with y. Negative 1 times our binomial is going to be negative x minus 3 squared, and negative 1 times 2 is a negative 2. Let's look at one last question. All right, first step here is going to be to divide everything by our a value. So we're going to divide everything by 3. So I have y over 3 is equal to x squared plus 10x minus 3. We group our first two terms together and rewrite so that we can complete the square. So y over 3 plus a value is equal to x squared plus 10x plus a value. So we take half of 10 and square it. Half of 10 is 5. 5 squared gives us 25. And we add that to both sides to keep it balanced. We rewrite our trinomial as a binomial squared. So we still have y over 3 plus 25 on the left. This becomes x plus 5 squared. Then we subtract 25 on both sides. We get y divided by 3 is equal to x plus 5 squared minus 28. Our last step is to undo that 3, so we have to multiply everything by 3. And that leaves us with a vertex form of y equals 3 times x plus 5 squared minus 84. And that is rewriting vertex into vertex form by completing the square.